Hello everyone, welcome to my presentation on cache techniques. So what exactly is a cache? Think of it like a super fast mini storage that sits right next to the CPU. It stores the data that the computer uses often, so the CPU doesn't have to keep running back to the main memory for it. That saves a lot of time. Why do we need cache? Imagine if every time you needed a book, you had to go to the library instead of your bookshelf. That's how a CPU feels without cache. Cache helps the system run faster, reduces memory traffic, and speeds up data access. Types of cache. There are different types of cache. We have the L1 cache. It's the fastest and is built right into the CPU. L2 is bigger but a bit slower. L3 is shared between CPU cores and helps with teamwork. And then there's software cache, like what browsers use to remember websites. Cache mapping techniques. Now let's talk about how the data actually gets into the cache. This is done through mapping techniques. The main ones are direct mapping, fully associative mapping, and set associative mapping. Each method has its own way of deciding where data should go in the cache. Direct mapping. With direct mapping, each piece of data is assigned one specific spot in the cache. It's super simple and quick, but there's a problem. If two data blocks need the same spot, one has to go. That's called a collision. Fully associative mapping. This one is the opposite of direct mapping. Data can go anywhere in the cache. That means fewer conflicts, but it takes longer to search the whole cache to find what you need. It's more flexible but slower to read through. Set associative mapping. Set associative is like a mix of both. The cache is split into sections and each data block can go into any slot in each section. It's more balanced, not as slow as fully associative, and not as rigid as direct mapping. Cache replacement policies. When the cache is full, we need to replace some data. There are few strategies for this. LRU, or least recently used, removes the data that hasn't been used in a while. FIFO, FIFO removes the oldest one that came in first, and random just picks one to remove. Kind of a lucky dip. Write techniques. When we change data, we have to decide how to update it in memory. Write. True write to both cache and memory at once. Save but slower. Write. Backs up. Backs up. Cache first, then memory later. It's faster but risky if the cache crashes. Write around. Write around skips the cache on write and updates the main memory directly. Cache performance terms. Some important terms you need to know. A hit means the data was found in the cache. A miss means the data wasn't there. The hit rate tells us how often we get hit. Miss penalty is the time we waste going to memory when there's a miss. Here are some real life examples. Cache isn't just for CPUs. Web browsers use it to store pages you visit often. CPUs cache instructions they use a lot. Databases like Redis using caching to respond faster to search queries. Okay, here's a summary. To wrap up, cache is fast memory that helps make computers run smoother. It uses smart techniques to store and replace data. It plays a big role in both hardware and software performance.